We're going to take a look at an example from section 3.1, which deals with functions and function notation. Specifically, we're going to spend some time working with domain. I'm actually going to pull number 78 from your textbook, which reads as f of x is equal to negative x squared plus 3. So we're going to pull in some of the information that we refreshed and reviewed on today. So one of the first things that I'm going to do is I'm actually going to go ahead and graph this. Okay. So let's set this up. Here's my x-axis and my y-axis. And 1, 2, 3, 4, 5. I'm just going to use tick marks, 5 tick marks within each quadrant. Okay. I think that I'll be okay with that much. So one of the first things that we want to recall is this is written in standard form. In other words, this is y is equal to ax squared plus bx plus c. And if it is written in standard form, we can go ahead and find out what the vertex is by first finding the x-coordinate for the vertex. And we can do that by using negative b over 2a. Okay, this is a nifty little trick that will save you some time. And what this will indicate, well, our b in this case, I don't really have one, so that would be 0, and our a is negative 1. And this ends up just being 0 over negative 2, or just 0. So I know what that will be. So I know what my x value will be. So my vertex here, it's going to have an x value of 0. In order to find the y value, I can now go ahead and plug in 0 for x, because I just found out what x was. And this is y is equal to 3. Okay. So here's my vertex. It's going to be at 0, 3. And you can use some context clues from the original problem. Notice that there's a negative outside in the front. This is going to indicate that your parabola will open down. Okay. But I can also figure out maybe what the x-intercepts are. And again, recall that the basic structure of an x-intercept is going to be where your y value is going to be 0. That's because that is where your graph is going to cross or touch the x-axis, and the x-axis is actually laying right on top of the tick mark where y is 0. So what we're going to go ahead and do is we'll put 0 in for y and figure out, getting ahead of myself. So we should have 0 is equal to negative x squared plus 3. Sorry for the mess. We can subtract 3 from both sides. And this gives us negative 3 is equal to a negative x squared. We can continue to simplify that down. And then we're going to go ahead and take the square root of both sides. So one thing that you do want to note is that you don't want to forget that plus or minus. Okay. Or else you're actually going to limit how many solutions you actually have. So I do have 2 x-intercepts here. I have one at root 3, 0, and negative root 3, 0. I would go ahead and just use your calculator for a decimal approximation for what root 3 is going to be, and then just eyeball it if you were asked to graph this. So this is about 1 73/100ths if you round to the hundredth place, and negative 1 73/100ths. So if we were to go ahead and plot those, that's about, I would say, here and here. And again, using your x-intercepts, this does indicate to you that from your vertex, your parabola is going to open downward. So the final part of the question, the whole point of doing this one was to kind of talk about domain. In other words, domain pertains to which values, your x values or your y values. If you said x values, give yourself a gold star or whatever color star you prefer. And what I would kind of indicate for you here is, okay, well, I want to know where I'm using these x values. Okay, so if you notice, you can kind of get a little bit messy. I'm going to go ahead and use this yellow. So notice at this point, if I were to drop all of these points from the parabola, they're going to strike the x-axis here. So I'm using all of these values right in here. And we can kind of use the same justification. A parabola continues to fan out infinitely, so I will eventually use all of these values here, because my parabola is going to continue to open outward. It's going to always fan out, so it will eventually use all of these x values. You kind of have to use your imagination a little bit, but hopefully my explanation is also helping. So notice that this parabola actually is going to use everything eventually. Okay, that's where the imagination and the intuition have to come in. So since I'm using everything, my domain will run from negative infinity to positive infinity. Just to give you a side example, if we had something like a square root function, okay, if I were to graph a square root function, it would look something like this. Okay, it's a very rough sketch, but if we're looking at the basic square root function, f of x is equal to the square root of x, this is what the shape and positioning will look like. It will start at the origin and it will just continue off into the first quadrant. In here, if you notice,